All right, everybody, our second video here is going to be dealing with angles and how do we graph them on the coordinate plane. So we have them in standard position. In class the other day, we defined that we have 0, 90, 180, 270, and then all the way back around to 360 degrees here. We could keep going multiple loops and add 90 every time, but that's what we have when we're looking at something measured in degrees. Now, what about radians? Well, our setup is actually the same. The only difference here is that, you guessed it, it's in radians and not degrees. So we have to take each one of these and convert it over to radians. So the first one, 0, is still just 0. What about 90? So we'll take 90 here, put it over 1, and multiply it by pi over 180. When we do this, we get 90 pi over 180. This simplifies to 1 over 2, or just pi over 2. So 90 is equal to pi over 2 radians. Let's keep going for 180. Put that over 1. Multiply by pi over 180. The 180s cancel, or simplify to 1, and we just have simply pi over here. Next, let's keep going. We have 270. Again, multiply by pi over 180. We have 270 pi over 180, and this simplifies to 3 pi over 2. So we can put that right here. And then finally, 360 degrees, multiply again by pi over 180 to convert to radians, and this is going to equal 2 pi. So when we see things measured in radians and we're looking to see, okay, where does it belong, what is our scale, we use these as our reference points now. We see, is it bigger than half of pi? Is it bigger than pi? And that's going to tell us which quadrant it belongs in. Quadrants are still the same. We just measure it a different way. Now, a few things to note and remember. This is still for both our initial side. We see our positive direction in green, and we'll see our negative direction in red. If you are somebody that feels more comfortable dealing in degrees, the radian fractions are too much for you, feel free to convert your measures back to degrees. To be honest, that's actually how I do it most of the time. I'll convert it back to degrees, and I'll sketch basically where does it belong on the graph. These graphs are the same. You can convert them back and forth. You can use whichever one is easiest for you to work with. And honestly, doing the conversion factors only takes about 30 seconds. So if 30 seconds is the difference between a right and a wrong answer on the test, I'd say that's a wise use of your time. We'll do a few different examples here and basically practice using where do these things belong. So let's take a degree measure, for example, and let's do a challenging one. So we did some of the ones that are more straightforward in class. What if we have something like 400? Well, that's going to be more than an entire loop. It's going to start here and go more than its fair share around. So how do we do this? Well, in these challenge ones, let's see. First, it takes 360 degrees to get back to the x-axis. So if we subtract 360 from that, we'll have 40 degrees left over. So if we look at graphing this, what we're going to see is that we go all the way around and an additional 40. So you can almost think about this as the same thing as a 40-degree angle with an extra loop. So here, that would be the terminal side of your angle. That would be the initial side of your angle. So this one would actually end up 400-degree angle, ends up in quadrant number 1. It goes through all of them, turns around, and stops in the first quadrant. So think about it, if you have a measure bigger than 360 degrees, just in relation to when it crosses that finish line again, where does it end up? And you can think about it as a simplified angle. You can think about 400 degrees as actually being similar to 40 degrees. Other things that we can go over here, let's try a radian example. So what if here we need to graph, let's say, 7 pi over 6 radian? Where would that fall? Well, you have a few options. If you want to convert 7 over 6 to a decimal, what you're going to see is it'll be like 1.17. And if you can see numbers easier that way, and you can see that, okay, this is 3 pi over 2, or 1 1/2 pi, you'll see that it's going to be somewhere in this range. You can also see that it's just a little bit more than 1, but definitely less than 1 1/2, because that would need to be 9/6. So if you can see that fraction in that way, that's also okay. But that's how we can look at radians, is again, still in reference to the endpoints of the axes. And like I said before, if you're somebody that hates looking at radians, convert it. Make this 180 over pi, the pi's cancel out, and this just becomes 210 degrees. And if that makes you more comfortable, if you know that this is 180 and this is 270, maybe it's easier for you to see that that's also the same thing as 210. Either way works. Do what is easiest for you, truly. So with that being said, that's the idea for graphing, converting between radians, and using those units of measure when you are actually putting them onto the graph. The final thing here, just remember, identify these quadrants. So 1, 2, 3, and 4. And if you're wondering, Mr. R, why do you always do the mood meter? Well, it's kind of a subliminal way to show you the quadrants. If you're like, wow, this actually looks familiar. Well, that's on purpose. So here you go. If you ever forget what the quadrants are, you can color code them and just think about that mood meter that we do every day to start class.